Okay, let's get started. Cross-site request forgery. Who's excited? I'm excited. All right, so this is, I don't know, I like this topic. This is a fun topic because, I don't know, it relates to security. I don't know why, but I get excited about security stuff. So let's get excited. First, a bit of a little logistical announcement. I forgot my phone today. The reason that's relevant is I can't see chat. So if there is anything going on in chat, just know that I can't see it today. So I'm not ignoring chat. I just physically can't access chat right now. If there are questions in chat, if somebody does want to raise their hand and shout them out, that would be awesome. If not, just know that I can't see chat. I'll be happy to answer questions the old-fashioned way. We'll just be in prehistoric times here. You have to raise your hand. It's all we got today. So exciting topic, cross-site request forgery. This is an attack that we need to be aware of, need to be protected against when it comes to building our web apps, that we are now vulnerable to, starting with homework 2, now that we have a form where people can submit authenticated information to us. We need to be concerned about this. And this is the last piece for homework 2. This is the application objective, is building these cross-site request forgery tokens that we'll talk about today. And then after that, everything for homework 2 is on the table. Friday, I'm going to do just a bunch of odds and ends, random examples. I'm not going to have any slides, and I'm just going to do a bunch of examples the whole lecture. Should be fun on Friday, but no new content. So after today, the whole homework is on the table, and your learning objectives 1 through 3 have been on the table since Monday, adding in the escaping HTML. And really before that, aside from the escaping HTML, you've had, I guess not quite a week, but about half a week where you could complete all the learning objectives. Yep.
Will there be a lecture question on Friday?
Oh yeah, there will still be a lecture question. Just no new content. My reason for saying that is that the homework is in your hands because this is the lecture where I did it. I said the homework is due on Monday. That's pretty quick, but there's no new content on Friday, and I'm still doing it right now. Next week, we don't have classes, and your team meeting would be optional that week. If you want to have it still, that would, I'm not gonna require it. When I have a week off in the schedule, usually it's spring break, but we have this in the fall now too. Whenever I have a week off in the schedule, in my mind, that week doesn't exist. It's just a complete void in the schedule. So when I say next Monday, homework's due Monday, you only have half a week to do it. That's me just completely blanking out next week in my mind entirely. It doesn't even exist. So if none of you want to think about 312 next week, I'm not going to force you. You don't have to. There's no, my expectation would be that you don't. Of course, a lot of you might want to work on it to get caught up. That's your own choice. That's fine. But my assumption is that no one will think about 312 next week. I'll try not to. I'm sure I will get caught up on stuff too. I want to get homework 3 and project 3 released. But effectively it doesn't exist. So any deadlines that would be next week are pushed back a week. And when I say next Monday, I mean, a week from Monday. Yeah.
Are there still office hours?
Office hours. Thank you. Monday and Tuesday, since the university has canceled those days, you should assume that office hours are canceled unless otherwise noted. If a TA wants to still hold office hours on Monday or Tuesday, I'll have them mark it on the schedule and say, hey, I'm actually having office hours that week. Wednesday through, I don't know if we have Saturday office hours, if anybody chose them for 312, but Wednesday and the rest of the week, they should be assumed to be having office hours unless I'm asking the TAs if they want to cancel their office hours next week, that they'll cross out their name on the schedule. If their name is not crossed out, you should assume Wednesday and onward that they will be having office hours that week. So office hours will follow the university schedule, I guess is the short answer to that. Any other questions? Let's do it. And just to make sure I reiterate it, your team meeting, I didn't even think of this because it seriously is just a void in my mind completely. But if you don't want to have your team meeting next week, that'll be optional. I don't expect any 312 stuff to happen. If you do have a meeting and you still want to submit the form, by all means, go for it. Still let me know. The meeting forms, you can fill them out even if you don't have a meeting associated with it. Let me not give any context or anything, but hypothetically speaking, if you try to have a meeting and the rest of your team just says, nah, I don't want a meeting, still fill out the meeting report form and say, hey, I tried to have a meeting. All my teammates just completely, flaked out on me and didn't care or anything. Let me know through the meeting report form. Plus, if there is no form submitted for you for a whole week, that's going to count against you when it comes to the individual grading. So even if your team didn't want to meet, fill out the form, let me know what happened, and then that won't be held against you. Of course, your other teammates, assuming they don't submit the form and your form says that they flaked, that's an easy decision for me, that your teammates are getting lower grades. I don't even have to think about that one. But still fill out the forms even if there was no meeting. And if you want to fill out the form, you have a meeting on Tuesday, and then on Thursday, you fill out the form and submit it and everything. Then on Thursday over Discord, your teammate says, you're such a jerk, I hate you. And you're like, why did you say that? Fill out the meeting form. You don't have to, obviously. But you have the option. Fill out the meeting form again. It doesn't have to be associated with a meeting. If you have something you want me to know, let me know. Preferably not in that. I don't want to get involved in your personal quarrels and everything. But if they said, hey, you're such a jerk, therefore I'm not working on the project, have fun, good luck, you might want to let me know about that, because now you have a lot of extra burden on you for the project. You have to do the project without that help. Let me know how to make them individual grade adjustments. But if you don't have a meetings report form for next week, that's not going to be held against you, is what I'm really trying to say here. All right, cross-site request forgery. Let's do this. And so cross-site request forgery, and then I put origin right away. The word origin hasn't even come up yet, but this is a cross-origin request. The cross-site request forgery, the X, whenever it's cross, they like to put X's. I don't know. I'm not going to stop them. It looks all right. But if you see CSRF, actually I prefer the X, obviously, because that's the one I use. CSRF or XSRF. It's a long day. I got a lot more to go. My brain quit on me a lecture ago. They're the same thing. Whether it's a C or an X, it's going to mean cross. But in web development, we like the X's for whatever reason. I mean, it looks neat, I guess. Sure. But it's also a cross-origin, sometimes called cross-origin request, which means you have a request from a different origin to another origin. Your origin is the combination of protocol, host, and port. So like HTTP localhost 8080, that's your origin. And if from that host, or from that protocol, host, and port, you try to send a request to another protocol, host, or port, something where all three of these don't match, or any one of them doesn't match, that's going to be a cross-site request or a cross-origin request. That's what we're talking about today. These are cross-site requests. And what's the danger? Why can't we just send requests to other sites? Well, if somebody can send requests when you go to a site, the danger is you go to a site and that site is sending requests to other sites. They can send requests to sites where you're logged in. That's where this gets scary, is they can send a request to Autolab, an HTTP request to Autolab. Autolab says, thanks for the request. I'm going to process this as normal. And they request all your grades or make submissions on your behalf, or they get your submissions and then submit your submission and get you in trouble with AI or something like that. They go to your bank site. They send a request to your bank and transfer all of your money to their account. Pretty scary. Or they just want to mess with you and make embarrassing posts to your favorite social media site. But if they can make requests on your behalf, you should be worried. When you're developing web apps, you should protect your users against this kind of attack. These are scary attacks that we need to prevent. These need to be prevented. Whenever there's a cross-site request forgery vulnerability, it can be a big deal. It can compromise a lot of users, especially when it happens to big sites. So let's be a little more specific on this. Your homework app now has a post request, an authenticated post request. Now, this is where we start being opened up to this type of attack, this cross-site attack. We have an authenticated post request, which for homework, it's chat. Of course, it could be the bank, Autolab, whatever. And you host this, you have this authenticated post that you host on mycoolproject.com. You're really happy with it. You publish it, you send the link out to everybody, and they're all enjoying your app. Everything's great. That post request has a specific format, and guess who knows what that format is? Everybody. Everything you put on your front end has no privacy, no security. Everybody can see your front end, everything. The HTML, the CSS, the JavaScript, the multimedia, it's all on the table. An attacker who has no intention of actually using your app can go to your app, view source, and look at everything of what's going on. They can fill out the form, send a post request, send something to chat, and look at the request and see the exact structure of that request, which means they can forge it. Well, hopefully not by the end of the lecture. But it means they can send a request that looks just like a legitimate request that came from your front end. Never trust your users. They might not be using your front end. They might be an attacker sending a request on the user's behalf. Never trust anything that comes to your server. Never trust your users. Because what an attacker is going to do is they make their app at freebitcoin.com and they get some sucker to click on their link. They send an email, hey, want free Bitcoin? Click here. They click on that link, and that link has JavaScript or anything else that means to send this post request to your app, a cross-site request that's going to hack your user. So they know the format of that post request. They write JavaScript. I'm going to send mycoolproject.com this post request. As the user, this is JavaScript running on the user's machine when they go to this site. So it's going to look like a legitimate request, but it's going to be sent by freebitcoin.com, whoever wrote that site, and they're going to send whatever they want, which is draining your bank account or posting on your authenticated post some silly, ridiculous thing. This is a cross-site request forgery attack. If you can get somebody to click on a link and there's a site out there that they're logged into, they have to be authenticated or else there's no real point. And they're logged into a site, they can launch this, if the site they want to attack is vulnerable to cross-site request forgery anyway, they can send these requests on behalf of the user and have them look like legitimate requests. Bad. This is bad. We need to protect against this. Very bad. To visualize this, you create an app. You got your app up and running. It's really great. Client comes around, says, oh, look at this cool site, registers an account, logs into that account. You give them an auth token, and you set that as a cookie. And you're going to say, if I see this cookie, that's this user, and I'm going to treat them as authenticated. That's how authentication works. That's what we built. That's just how it works in the world. They enjoy your site. Everything's going good. And then they get this email. And they're like, oh, man, I'm going to click this thing. This is going to be great. My whole life's finally turning around. They click on this link, which sends them to freebitcoin.com. Freebitcoin.com says, oh, you're visiting my site. That's cool. Here's my HTML, CSS, and JavaScript. Here's the front end of my site. The JavaScript runs on the client's machine. The JavaScript runs on the client machine and says, oh yeah, we're sending this request over to mycoolproject.com. And all of a sudden, they're compromised. They get this cross-site request happening because they visited this site's JavaScript sent from the client, not from the attack site. Your mycoolproject.com does not know this attack site was involved at all. Well, they can. There are things we'll talk about. But they don't know that site was involved. They just see a request from this user. That request has that user's auth token in a cookie because it came from them. It's an authenticated request, but it's doing whatever the attacker wants. We need to protect against this one. This is a very, very scary attack. It's a little more sophisticated. It's more sophisticated than the last ones we talked about, the I forgot to call it by name, but cross-site scripting, when you inject HTML that has JavaScript, the cross-site scripting, the SQL injection can get pretty sophisticated, actually. But this one's a little more sophisticated and a little tougher to protect against, if I'm being honest. If you don't have protections in place, this is an attacked user. We're going to hope the demo goes great. Okay, so I have my wonderful app here. Let me refresh just to make sure I got the latest JavaScript. I'm going to log in. Super secure password, lots of entropy. When you log in, you don't have to do the redirect. I was talking to someone in office about this yesterday. You don't have to do the redirect for registration or login because a very specific reason. I forgot to put it in the homework doc. So you're off the hook on it. That's why I had those redirect slides. I intended to have that in the homework doc where you had to redirect. So if your page loads like this, that's why in the, which I knew this when I was writing up the tests and procedures, but I just completely blanked on it. When I was writing up the tests and procedures, I say, if another page loads, navigate back to the home page. This is what I mean. If you have literally anything that loads up for login or registration, you can navigate back. That's part of the tests and procedures, is to get back to the main page. And then when I submit to chat, I'm authenticated. Let me bump this up a little bit. I'm authenticated, has my name. That means I'm not logged in as guest, and I can see my auth token. Let me blow this one up too. My auth token is right here. I have a valid auth token. So everything's working the way we expect it to, and then comes along aptly named server 2. I gotta find where I'm at. There it is. Server 2, running on, I know it's hard to see the URL, but localhost 9000/shadylink, which is not localhost 8000. So since my protocol, host, and port do not match, this is a cross-site request. Because the origins do not match, I have different port numbers. That means these are treated as different hosts. Even though they're both on localhost, they're both on my machine, this is going to be treated as a cross-site request from the browser's perspective. And this shady site is going to make posts on my behalf. I meant to remove this one. That one I want to talk about later. But it's going to make a request on my behalf from the shady site. It sent a message to my other site that contained my auth token with whatever payload I want, which I just choose whatever message I want, which is going to look like I actually sent that in chat, but all I did was go to some shady site, which is still pretty bad. I deserve that, right? But I can make that cross-site request from another site. So this is what we want to prevent against. The way I did that in this attack site, let's take a look at the code, because there are multiple ways to do this. One, we can do the 1 pixel. This is what the one that showed up as guest is. I'll talk about that in a bit, but I can show the code right now at least. The 1 pixel image, this is pretty common. Have a 1 pixel image. This is common with like social media sites too, the tracking stuff. The image, there's a few things you can do here. The source of an image, I can actually put a full URL here if I want. I didn't. Instead, I chose to use the onload. This is what I used for the cross-site scripting last lecture as well, as I used an onload and then called any JavaScript and then have my JavaScript, which, yes, I have in the HTML just for the attack site. I figured an attacker is not going to be sophisticated enough to have separate files. It is actually what I thought when I did this. But that's going to send an AJAX request over to chat messages with whatever message I want. The other form, the one that actually got through as an authenticated request, notice that one showed up as guest. The other one that showed up as an authenticated request is making an HTML form where the action is an absolute path to the site that I want to attack. I can post This actually didn't work. I was just playing with things. On submit, return false. I was trying to do it without getting the page to reload, which I'm pretty sure is impossible in this case. And then putting whatever message I want to send to attack them with. And then on load, I'm going to grab that form and submit it. Again, this is me trying to get the page to not reload. This didn't work. I can just delete this. I was trying to get the page to not reload. It didn't work. I'm pretty sure for good reasons. I feel like I understand why that is the case now. And then submit the form. So I didn't even have to click a button. I didn't have to get the user to click a button. As long as they click the link, as soon as the page loads, it's sending off that request without the user doing anything else after clicking the link. Not that one. So I hacked myself. I did that in 2 local hosts with different ports, but that could be any 2 domains on the internet. That's how they're going to attack each other. Yeah.
Why is the JavaScript function calling be associated with the image instead of just running a script?
Wait, what was that? Why is the JavaScript in an image? Why didn't I just do that in like the body onload? No, I have a good answer here. I don't know the shortest way to say it. I'll just spoil the whole thing. It's not that big of a spoiler. It's in like 2 slides. But if I can get an image, I can get an image in an email and send you an email where I don't have control over the whole HTML. So it's a lot easier to inject an image somewhere. Or if I have an HTML injection vulnerability that I can exploit, I can get an image in there with very little control over the rest of the thing. When I have the whole page, I have full control of the full page, then I would just do body onload. Wouldn't be as hard. I can just do whatever there. But the fact that we can get it in an image makes it scarier, makes it more likely that an attacker doesn't even have to get you to click a link, which just increases the scariness of these things. So how do we get them? Oh, it was the next slide. So how do we get them to get our JavaScript running, our code running on their machine? Putting it in the source of an image, probably the most easiest, most straightforward way to get any GET request. This is the source of an image, so not the onload like I just did, but the source of an image is going to make a GET request for that image. And it's going to look innocent enough to any server, but we can only send GET requests this way. This can be scary, and this is something we need to think about when we build our web servers, if you're abusing what GET requests can do. So if you have a path where somebody can submit information to your server, and you're like, I don't feel like making it a post. I'm going to make it a GET request with a query string, and they're going to send me the information that way. Maybe I want them logging in with GET requests. You have the power to do that. You can put username and password in the URL itself. You shouldn't for a lot of reasons. URLs are not as, never mind. But for this reason, at least, we'll say it here. If you have a GET request that's going to have access to sensitive information, no, that's not true. That's not a problem here. I have to be careful with the way I word things because some things are technically not problems. But if it's a GET request that sends information to a server, say you have a GET path that's going to change somebody's password. You send your old password or new password as query string parameters, and you can change your password with a GET request. You're super vulnerable to cross-site request forgery attacks because anyone who can get you to load an image is going to be able to exploit that by sending a GET request. The reason why I'm tripping over my words there, the reason why your GET request returning private data, well, we do that all the time. GET requests can return private data. That's not an issue here because the attacker can't see the response from that GET request. The browser can, but the server can't because that request is happening from the browser. So that one's not actually a concern. But if you could have GET requests that can change the state of the server, especially authenticated state that should be authenticated, you're wide open to this type of attack, putting that GET request with query string in the source of an image. You get somebody to load a page containing one of those images, it's done. It's over. They're compromised. And this is why images are often blocked. I mean, our Outlook goes way too overboard on this, in my opinion. Way too much, way too hyper paranoid about security, which I guess is good in certain senses. But that's why images are so blocked in email, because any email, if you can get somebody to click a spam email, you might not get somebody to click the link in a spam email, but you can get somebody to open the spam email. And if they open it and say show blocked content, and there's one of these such images that attack a site that you're logged into, you're compromised. If you you could submit an HTML form. This gives us a little more power. This is the one that I showed that was successful. With an HTML form, we get them to navigate to a page, so there's a higher bar here. They have to actually go to our page, go to our attack site, which has the HTML form with the input, with everything that we have set up. We have to have it all set up the right way. And then the page can automatically submit the form. We don't have to have them click a button. They just have to click the link. Once they click the link, they're toast. They're done. But they click the link, and now with this, we get more power because we can send post requests. And servers should be using post requests to be able to change the state of the server. So now the attacker can do a lot more. They get these post requests. We're limited in that we can only send plain text and in specific formats. The attack that I did, it actually had, I don't know if I'll have time to go through the whole thing of that. Yeah, probably not. But I had to have an equal sign somewhere in there. And then I took advantage of that and just had an equal and made the post that I made. But I had to have an equal sign because I had to have the key value pair. I changed the encoding type. We haven't even talked about encoding types in forms yet, but we will next week, which means not literally next week. But post with only plain text bodies. So we're limited to just get in post, or the attackers are limited to just get in post, and they're limited to plain text bodies with specific formats. So there are restrictions with this, but this is a good way to get a lot of attacks through with an HTML form. This, in my opinion, is the scariest one right here. Submitting an HTML form when somebody clicks a link. And then there's Ajax, good old Ajax. With Ajax, you get the user to navigate to your page, and you can write JavaScript that does anything, right? JavaScript with Ajax, you can do anything. You can send requests. You can, importantly, receive the responses. With the HTML form, you're sending that user that you're attacking, you're sending them to the site that you're attacking. Because you submit an HTML form, what loads is the page that loads. You can change that. We did see a way to submit the form and override that page reloading. And I was trying to do it in my attack, but you kind of can't do it. The way we overrode it, though, was by sending an Ajax request. It's not going to, we can't launch this attack and not have the page reload is another important restriction. So only get, only post, only plain text with specific formats, and the page is going to reload to the attack site. And the attacker can't see the response of the request, so they can't steal private data. They can only send data on your behalf, which could be transfer all your money to my account. They don't have to see the response to that one. They're going to see it in their bank account. With Ajax, they can do anything. They can see the responses. They can launch multiple requests. They can have requests that have a conversation with your server, whatever the response is, react to that in various ways. They can do anything with Ajax. Full control, absolutely anything, any HTTP method. They can do anything with this one. So Ajax is by far the scariest. I think the previous one's the scariest, and I'll explain why. But this, if you're vulnerable to Ajax, you're absolutely done. Once an attacker finds out about that, everything is done. It's done. You need to protect against that. So how are we going to protect against these things? The one I want to knock this out of the way right away, because this is one of the first things that a lot of people would think of. If you're looking at this problem and I just didn't tell you anything beyond what I just told you, and I said you have to protect against this, one of the first things you're probably going to try is looking at the refer header. Whenever you have a request, you've probably noticed this in a lot of your testing, is you'll have the refer header, which has the origin of the request. So that's domain and port. You already know HTTP from the request line, but domain and port of the request. And if that doesn't match your app, like, it's It's cross-site requests. Don't allow it. Simple. The problem with this is refer can be spoofed. There are a lot of ways to spoof that. It's just an HTTP header. You can change that. The browser should enforce this, but some users will install plugins that remove that enforcement. There are ways to get around this one, so we can't rely on that. The refer header is useful in a lot of contexts. This isn't one of them. We should not be relying on it for security purposes. That's not going to be a foolproof security plan. It might get rid of some attackers, but there's still going to be at least one user out there that they're going to be able to attack who's vulnerable to refer spoofing. So we don't want to rely on that one. The same origin policy is going to be a much stronger prevention method, I guess. This is implemented in the browser, and the punchline is going to be we can't rely on this one either, but I want to talk about it. This is implemented in the browser, and it blocks a lot of cross-site requests just by default. Your browser will just block these things. This is why Ajax, I say, isn't as scary as the form one, because it'll just block the Ajax. Any modern browser these days will not allow cross-site Ajax, period. Done. Don't have to do it. Don't have to worry about it. I mean, we do. But the same origin policy implemented in the browser just says no, which is great because Ajax, man, the damage that can be done with those things. Good thing that we had the same origin policy. We didn't always. The internet used to be a lot more dangerous place. Same origin policy is one of the things that have made it, bless you, made people a little bit safer out there. So update your browsers if you haven't, seriously. And the same origin policy does not block what it calls safe requests, which is any GET request. So embedding the source of an image, having an attack link in the source of an image is still on the table. That can still get through the same origin policy. So you need to be protecting your GET requests. We talked about item pwn's before, but they also shouldn't change the state of the server. That's what your post requests are for. That's what your put requests are for. That's what your delete requests are for. Same origin policy isn't protecting any GET request. Make sure you're not abusing what a GET request can do, or else you're giving up some of the protections that are in place for you. And the reason why I say HTML forms is the scariest form of this attack, no, I'll say pun intended, but I actually didn't, is that it's considered a safe request. HTML form submissions are considered safe by the same origin policy, so these are not blocked. These are on the table. This is what I used to attack my site successfully. Same origin policy did not block anything. It just happily ran the request, attached my auth token to the cookie. The browser happily just fired that thing off. This is not protected by same origin policy. HTML form submissions are not blocked. If you override the form, if you start messing with the form and override its default behavior and use it to create AJAX requests, then it's protected because it's an AJAX request. But an HTML form submission that's untampered with is going to reload the page with the response, and the attacker can't see the response. The same origin policy is protecting privacy. You can't read, the attacker can't read the data coming back from that request. They can just send you off with that request. But that means they can still send a post request on your behalf that is authenticated. So even if we're banking on same origin policy working the way it should, we're still vulnerable to these HTML form attacks. And there are limitations. We can't always rely on the same origin policy. This is enforced by the browser, and guess how much control we have over the browsers? Zero control. And all our users are going to have different browsers, different versions of browsers. Somebody might still be on Internet Explorer. Somebody might be using a browser that of a version that predates the same origin policy. You can see anything out there. When you deploy a real app to millions of users, you're going to see everything. And some people might not have the same origin policy enabled. Some developers are sometimes the worst users. Some developers will disable the same origin policy. If you're debugging something, you're writing code and you're debugging something, how many of you have done this? You're debugging something, you don't know what to do, you Google the issue, whatever the first link says, copy, paste, hey, problem went away. One of those copy paste might be disabling the same origin policy. And then, of course, you have an issue later. It worked on my machine, and then the real world has the same origin policy, and it doesn't work out there. Some developers don't know, might not even know that they've disabled the same origin policy. So a lot of things can go wrong here. It'll get most of our users, but there are always going to be those users that make themselves vulnerable in one way or another to these. And also, it's not protecting against the HTML form attack, which is why I say the HTML form attack is the scariest version of this one, because by default, you're not protected. None of us are protected against that HTML form attack. So our server has to protect against that. We have to be thinking of that as the web app developers. It's not even anything irresponsible that the user did with the outdated browser or anything. We're still vulnerable to that. So our form of prevention is going to be server-side. We need server-side protection. So no matter what that user's doing, or if it's an HTML form attack or an image source attack, no matter what it is, we want to be protected. And that's going to be our cross-site request forgery tokens, which if you've looked at the homework, that's what our application objective is to implement these cross-site request forgery tokens. This is going to work for every user in all cases, for every version of every browser. It's just going to work because it's a server-side protection. So let's talk about how these things work. This is going to be our silver bullet, our be-all, end-all for cross-site request forgery attacks. I say that so strong. There's going to be like one specific attack that could possibly. I don't see it though. I don't see how they could get around this without just launching. I feel like if they're getting around these tokens, they're launching a different type of attack. It's no longer a cross-site request forgery attack. They have to be doing something more intense than just this. They'd have to like get the user to install a plugin or something like that if they're getting around these tokens. So what we're going to do with a token is when a user visits the page, and I've had questions about this, let me get the answers out there. If you don't want to do this per page load, if you want to do this per user session, so generate these at login, that's fine. If you want to generate these at registration and have them on a per user basis, so each user gets one token and that's their token forever. Every time they visit the page, that's the token they get. That's fine. For your homework, I'm fine with that. In practice, either per page load or per user session are fine still. And some apps use cross-site request forgery tokens a little different than we'll describe, but they get the same effect with pros and cons to each method. But for your homework, page load, per page load, per user session, or per user, all of those I'm going to be fine with, as long as users can't use each other's tokens. Okay, so what happens is on page load, I'll say on page load for the slides for the lecture, is we're going to generate a cross-site request forgery token for that user. We're going to embed that token in the page, and this is where HTML templates are going to come in for the first time. Unless you want to set this up with some Ajax magic, you can do that, that's fine. But you're probably going to want an HTML template here to embed this token into the page, and then store this cross-site request forgery token associated with that user. When you generate a cross-site request forgery token, you're generating it for a specific user. And that's very important. That's absolutely crucial here. Generate a token for that user. And then in the browser, that token is going to be embedded in the HTML somewhere, usually as a hidden input on a form. And then whenever you submit the form, so whenever somebody sends a message to chat, that message is with JSON, with Ajax. So you would read your hidden input with the token, or however you want to encode this into your HTML, and then add that to that JSON object. The JSON object by default just has message and then the message thing. You would add another one, cross-site request forgery token, and then the value of that token. That's the intent for the homework. Again, as long as the testing procedures work, you can set it up a different way if you want. Now on the server, we get a request. We get this authenticated, there's this request that has to be authenticated. Somebody's posting to chat. We're going to put their username on this chat message. So this action has to be authenticated. We don't want anybody just sending messages on somebody else's behalf. That's the whole thing we're preventing here. So it's an authenticated HTTP request, and it should have this token. We're going to read the token, the cross-site request forgery token, and the auth token. We have two different tokens in this single request. We're going to use the auth token and do our auth stuff that we've done last week. We're going to do all our auth stuff We're going to take that token, hash it, look up that hash in the database, and pull the user for that request. If something goes wrong there, it's an unauthenticated request already. We don't even have to look at the cross-site request forgery token. But we're going to use the auth token to verify the user. And then when we pull that user's record, that's where we should have the cross-site request forgery token stored for that user. And then we're going to verify if the cross-site request forgery token is a valid token for that user. For that user. It can't just be a valid token. It has to be a valid token for that user. And I say a valid token, you can have multiple. Like if you're doing per page load, you don't have to do this on your homework. It just adds complexity without more learning. But what you can do in practice is have multiple tokens per user. If somebody has 2 tabs open, they might have 2 different tokens if you have them on a per page load basis. So you can store an array of tokens for each user. But if it's a valid token, not necessarily the valid token, that's why I say on the homework, some people want to do the per session or per user tokens. It just makes it easier. You don't have to store a data structure of tokens or even think about that. And you're still protected against the attack. So we want to make sure that token is a token for that user. It has to be a valid token for that specific user. If it's not that user's token, it's an invalid request, and you're going to reject that request. You're not posting that to chat. You're not transferring funds around. You're not respecting that request at all. You're probably sending a 403 not authorized to the as an HTTP response. If it is the right token, accept it. But if it's not the right token for this user, if everything else goes right, you pull the user's profile and everything, but this token doesn't match, or this token just doesn't exist, something went wrong, that's not, you can't accept that request. It might be an attack. It might not be. Something might have just went wrong. Might be a bug. Who knows? But you shouldn't request that, respect that request. And usually it'll look something like this. This is a form that'll upload images, but this is the key part here. You have your cross-site request forgery token, just some random garbage. You should have enough entropy here, just like your auth tokens. You should have enough entropy that no attacker can guess it. As the value of an input, give it a name. So that's the name that's going to be sent to the server, and then mark it as hidden so it's not displayed to the user. You, using the internet, have never known or cared, unless you actually looked into it, that you have cross-site request forgery tokens in the HTML of a lot of the pages you visit, because you don't have to care. We want to hide that from the user. Nobody cares about these except us when we're building this stuff. So make it a hidden input, just hidden as an attribute with no value. And then add this. This is rendered server-side using an HTML template is the intended way. If you want to do it, again, a different way on your homework, as long as it protects against the attacks, I'm fine with that. But the intent is an HTML template where you inject this value into your HTML on page load. So now that cross-site request forgery attack goes through, your server gets that request, says, hey, this cross-site request forgery token is not valid and does not respect the request. Whoever's running freebitcoin.com has no way of obtaining a valid cross-site request forgery token for this account. They can't do it. So now they are completely stuck and they can't launch this attack at all. Now they can get a valid cross-site request forgery token. They can go to mycoolproject.com and get a cross-site request forgery token, but it's going to be associated with their account. They can try to send an attack to mycoolproject.com on behalf of the user, but they can't read the response. So they can't get the token. They can't get a valid token that way either. If you're open to AJAX attacks, well, now the door is open and this probably isn't going to work, because now they can get a valid token. But with the HTML form attack, where the attacker page loads over to mycoolproject and they can't see the response, with the source of an image attack, they can't see the response. They can't get these tokens. They can't get valid tokens. So they're not going to be able to launch these attacks. And we had similar protections with cookies. So recall the same site directive with cookies. We had lax, strict, or none. None means the token's always set on these cross-site requests or third-party requests, as I call them in this slide. None means always send the cookie. Strict means never send the cookie unless the origin matches the request, the requested server. And lax is the default. This is what's going to be the default these days. Kind of a more recent thing, 2018, I believe. Lax is the default for cookies. And this means that the cookie is only going to be sent on safe third-party requests, which are GET requests and those form submissions. So that form submission, even though I have lax on my same site by default because I didn't set any, it's still going to send that cookie. So here's another avenue of attack. Strict. Same site strict on your auth tokens is going to be one more layer of protection against this. Again, this is client side. It's up to the browser to enforce this. If the user's using a browser that doesn't understand same site directives, it's still not going to work. It's still not going to be 100%. But those lax cookies are still sent. But on those AJAX requests, maybe something breaks down and somebody's able to launch a barrage of AJAX requests, cross-site AJAX requests. Those cookies won't be there. None of the cookies will be there because they're lax, unless you explicitly say, yes, send my cookies to everybody. If you're doing that with an auth token, you're doing it wrong, though. And finally, cores. How much time do I got? Oh, none. Cores, so same origin policy can be a bit restrictive in times. That's why some devs are encouraged, or not encouraged, but are tempted to